In the last lecture, I have given one homework question, that is, in f of x is equal to mod x whole power 3, whether this function is differentiable or not. That is the question. How many of you got the answer? If you got the answer, kindly drop your answer in the comment section. If you are really understanding the things whatever that I am delivering here, don't forget to click that like button and share it with all your friends. So let us see the solution for this question. Actually, here the question is given as mod x equal to whole power 3. If it is directly given like this, then if you are asked to check the differentiability, you know the procedure. First thing what you will do, we have to break the limits for mod x. How will you break it, sir? This can be written as minus x power 3 when the value of x is less than 0. It can also be written as plus x power 3 when the value of x is greater than 0. It is also equal to 0 when x equal to 0. So, this is the way we can simply define this. Next, if you check the left hand side derivative of this function, what you will be getting? If you go up with the left hand side derivative, this formula can be written as limit x is approaching c minus, function can be written as f of x minus f of c upon x minus c. Further, I can write this function is limit x is approaching to, here in our case x will be 0. So, directly I can put 0, but it is 0 minus since we are travelling along with the left hand side derivative, and the value of f of x will be equal to minus x power 3 because it is left hand side derivative. What is the value of f of c? F of c we have to find c. F of c means exactly at x equal to c. X equal to c value is 0. What is the value of f of x? So, f of c is 0 at x equal to 0. So, I can directly put that value here. In the denominator, x minus c value also 0. If you derive this function continuously, it can be further written as minus x power 3 by x. One x will get cancelled out. Anyway, it will be minus x power 2. Finally, what I am getting. What is the value of x? X is approaching to c. What is the value of c? C is 0. So, x equal to 0 only. Directly, if I will substitute 0 here, left hand side derivative will become 0. Okay, sir. So, we got the conclusion for the first function. Now, let us take the second. In the same way, if I am talking about right hand side derivative. So, right hand side derivative can be further defined as limit. You all know it is not quietly effective. Yes, let us see. So, x is approaching to c plus, and the function can be further written as f of x minus f of c upon x minus c. Okay, sir, fine. Now, in the next step, I can say limit x is approaching to 0 only, but from right hand side. In the numerator, you can say f of x is what this time? It will be plus x power 3 because right side derivative x power 3 minus f of c is 0 upon x minus 0. What is the conclusion? Once again, if I will derive this, it will become x power 2 because one x will get cancelled out. Anyway, x is approaching to 0 only. This is also will become 0. What is the conclusion? Sir, it is clearly visible that the value of left hand side derivative and the right hand side derivative are equal to each other because both are approaching to 0 only. So, the conclusion is given function is differentiable. But in the last lecture also, I have been asked you to check whether the first order derivative also differentiable, second order derivative also differentiable, because sometimes in your examination they will be asking you check whether the mod x whole power 3 first order derivative is differentiable or not, second order derivative is differentiable or not. See, what will you do for that? First order derivative means this is f of x. First order means you have to differentiate this function f dash of x such that what you will be getting. If I will differentiate x power 3, it will become minus 3x square. Limits are same. It will be since x is less than 0 only. Second, it will become plus 3x power 2. The second one is where the value of x is greater than 0, and this will be 0 when x equal to 0. Now, you can proceed the same procedure and check whether this one also differentiable or not. Suppose if they are asking you to check the second order derivative, then what you have to do? One more time differentiate the same function. You know how to proceed that will give you minus 6x. Here it will become 6 plus 6x. Here it will be 0. Limit is same, x less than 0, x greater than 0. Here it will be x equal to 0. Again proceed with the same. I hope you all understood how to find the differentiability of the any given function. Now, let us see what is this actual differentiability and why we are doing this, and how to check this one. See, when you are taking any function and if you are trying to differentiate, if you are finding to check the value of left hand side derivative and right hand side derivative also, basically derivative means it will be dealing with a tangent. It will be dealing with a tangent. Even if you observe, actually I am writing the formula for tan theta only. Whenever I am trying to write the function f of x minus f of c upon x minus c, basically this is tangent curve. If you are observing any graph, suppose see, I am showing you some graph here, clearly try to understand this. 1 minute. Yeah, so let me draw a little bit neat. So let us take y axis and x axis. Suppose a graph is given like this as usual. Sir, if a graph is given like this, if you draw the tangent curve at any point, if you draw the tangent curve at any point, let me take this point. In this tangent curve, see, this tangent is touching both neighborhood points. Neighborhood points means if we zoom the selected point, that point will become like this. So this is the selected point. Neighborhood points also, see, when I am traveling from neighborhood points from both left hand side derivative and right hand side derivative, this tangent will exist or not. That is basically mean by this derivative, whether the given function is differentiable or not. In order to know that, if I am deriving it from both left hand side and right hand side, that resultant value should exist and it has to give the same value. That could be possible, and you can also easily understand by drawing this tangent curve. Sir, how it is possible? See there, what I did here, I don't know whether you understand this or not. See, let me do it again. What I did is, I have taken a graph. I am selecting one point. For that point, I would like to draw the tangent curve. If I will draw the tangent curve and I will close the tangent, after drawing the tangent curve, if you are trying to getting close to that from the both left hand side derivative and the right hand side derivative, this will give you the same answer. That's all. After finding the derivative of the function from both left hand side and right hand side, if it is giving the same answer, it means what? In the tangent point, that curve is existing or the tangent is existing for that curve. So that is the meaning of this actual derivative. So if you take one more slope for that, suppose if I am taking mod x, if you observe, mod x is not differentiable. Why it is not differentiable? Because at x equal to 0 it is not differentiable. At x equal to 0, if you draw a tangent, what will happen is, only at x equal to 0 this tangent curve is touching, but rest of point, neighborhood points are traveling in this direction. So if you are traveling from the left hand side derivative or right hand side derivative, there will be no points from the left hand side or there will be no points from right hand side from your curve. Tangent line is going like this, wherever your curve is going in this direction and this direction, they are not touching them. So that is the actual meaning of the tangent. Tangent means we have to take some slope. In that slope, when I am drawing a line in a particular point, in that particular point from the both left and right hand side, neighborhood points also getting close to each other. Neighborhood points actually has to touch your tangent curve. That's all. You can take like that. So in case of this one, no sir, my neighborhood points are not touching, they are traveling in some other direction. Even if you take circle, if I am drawing, assume that is circle. If I am drawing a tangent line, see there, from the selected point, if you observe, neighborhood points are touching your tangent curve. So then that function is differentiable. If it is not, then that is not differentiable. So that is the actual meaning of the derivative. So what we are doing, so we are practically using this relation. So for whatever the question that we are taking, in that questions I have directly applied this formula. This tangent equation has been derived from the graph only. We have to take 2 points from the x axis and 2 points from the y axis. So that will be basically indicating the slope variation in y with respect to x. That is simply called a tangent. In y, what we can define? y2 minus y1 divided by x2 minus x1. So the changes in the slope. So that is basically we are defining it as tangent, and we are checking while drawing the tangent curve at any specific point whether the neighborhood points also touching the tangent curve or not. If it is touching, yes, that function is differentiable. If it is not touching, then the function is not differentiable. That is the actual meaning behind of this all things. Anyway, the thing is, whether you are understanding these things or not, you have to understand how to proceed with the question. That is very important. So sometimes see, we are going up with a very brief introduction and a very brief explanations. Here also I haven't given actual definitions and actual things in front of you. So what you have to do is, suppose if you are not getting the complete idea, no sir, I have to see the deep meaning of all these things, then kindly visit our website www.rkelectricalgrid.com. Electrical grid, just type without space .com. Then you can it will be when entering into our website, there you can find all separate playlist for all subject with the chapter wise. So you can just log into that and you can see the in-depth explanations for each and every concept. Okay, elaborately you can see. Anyway, that much of things here it is not required. Basically whatever the things that I am derived directly here, with that help of concepts you will be able to solve all questions. So this is all for this lecture. Complete differentiability is over. In the next lecture I will be come up with a new topic. Thank you all.